All right. So today and tomorrow and possibly a little next week, we're going to take a slight break from our whole polynomial discussion, all right, which we've been talking about this whole time. Uh, and we're going to specifically talk about complex numbers. This may be some review from last year, okay, but that's all right. I'm going to take our time here and make sure that you guys get it. Okay, so before we begin, let's consider the equation or the function x squared plus 1. Okay, I want to find its zeros, right? I want to find the x-intercepts, its solutions. So, I mean, one thing we can do is we can look at the graph. Did I get rid of it? No. Okay. So here we can just look at x squared plus 1. All right. We go down, and when we look at the graph, okay, it doesn't cross our x-axis. So that's kind of an issue, right? We know that from the rule that we talked about last week, this is an x squared, so there should be two solutions. But again, according to our graph, right, what we see, there are no solutions. Okay, so we have to add a little asterisk, and we're going to say that there are no real solutions. Okay, and what we mean by that is in mathematics, we have something that are called imaginary numbers. Now, they are actually used in real life in things like optics and electrical engineering. Okay, so if those are things that you think you might be interested in for college, okay, you will be dealing with imaginary numbers. So when we go solve this algebraically, right, we would subtract 1 from both sides. We would take the square root. Now, don't forget, anytime algebraically we take the square root, we have to put a plus or minus. Okay, so we end up with x equals plus or minus the square root of -1. Now, this poses a big problem. There is no way you can have a negative under a square root, right? When we talked about the square root function, when we were talking about our graphs and things like that, the domain of a square root, right, x had to be greater than or equal to 0. Okay, because conceptually, the square root is telling me what two numbers or what number multiplied by itself gets me that number x, right? So I can't have, obviously 1 times 1 doesn't equal -1. -1 times -1, that equals +1, so that doesn't equal -1. But again, this problem, something like this might come up, in physics. Well, we need a solution. So the solution was, if you come up with the square root of -1, that's going to be our imaginary number I. Okay, I do my eyes a little fancy like that, so you don't get them confused. Right, but you could just say I as well. All right, so here we have our we call what's an imaginary unit. Okay, we have some properties of this. All right, so if I had I squared, right, well, that would be the square root of -1 squared, which would just be -1, right? And then we also have I to the 4th. Well, if I squared is -1, that would be I squared times I squared, which would be +1, right? And then it's periodic, it's cyclical. So I to the 5th would just be I to the 6th would be -1, I to the 8th would be +1, and it would just keep repeating like that. Now, all of our solutions might not just be the simple where it's just the square root of -1, where it's just I. Our solutions can take more, keyword here, complex forms. All right. If we have an imaginary solution, it could fall under a complex number. All right, so let's talk about. Okay, so we have A and B. They're going to be real numbers. Okay, so here we have the expression A plus BI. Well, that's going to be what we call a complex number in standard form. The A, we say, is the real part. And the BI together is the imaginary part. Okay, so we have some things that go with this. If the imaginary part, if b equals 0, well, then you don't have the imaginary part. And then this expression is just going to be a real number because all it is the real part. Okay, and that's when we see when we have a solution like x equals 2, right? Technically, it's a complex number. It's just that the imaginary part is 0. Okay, if b doesn't equal 0, and we have a full expression, okay, so like 2 plus 3i, then that we call an imaginary number. Okay, and then we might have a case where the a part is 0. So then your expression would just be the bi, and we call that a pure imaginary number. All right. So any questions so far? All right. So this is all kind of like side note stuff. So just if you hear me reference one of these terms, okay, just know that's what it means. All right. So there's a concept with our complex numbers called the equality of concept of complex numbers. Okay. And this is kind of self-explanatory. It might seem like common knowledge, but if we have two complex numbers equal to each other, okay, a plus bi equals c plus di, right? Then a has to equal c. They have to be equivalent, and b has to equal d. They have to be equivalent. There's no way around it. right? They wouldn't be equal if those two parts were not also equal. Okay, so now some of this stuff you may remember, hopefully, from last year. Right, and these are basic operations with complex numbers. All right, so if we're adding two complex numbers together, okay, what you're going to do is you're going to add the real parts together, and then you're going to add the imaginary parts together, and then just tag on the I with it. Okay, the way I like to explain this, again, I'm not sure how you did it last year. It's kind of like combining like terms, like we do for normal variables. Okay, consider I as just another variable, like x, right? So these would be the constant terms, and you would combine the constant terms together. And then these you would be combining like terms because they share the same variable I. But again, obviously, I isn't a variable. A variable is something that we don't know, but instead I is the square root of -1. That's an equal sign. Okay. Same thing goes when we subtract. Okay, if we're subtracting two complex numbers, we subtract. Oh, wait, I did this wrong. Sorry, guys. You got to correct me. That should be a C. Okay, so if we subtract, then we're just subtracting the real and the imaginary parts. All right, let's take a look at some examples. Just a quick, how much of this do you guys remember, or do you want me to keep going with review?
Remember any, Mr. Murray?
Okay, all right. All right, so here I'm just going to say be careful of your signs. Okay, I always say that. Okay, so just make sure that you're keeping true to what they're telling you. Okay, yeah, let's start with this. All right, so we're going to take a look at 7 plus 3i, and we're adding that to 5 minus 4i. So sometimes you'll see it where it's in parentheses like that, okay? But as long as there's nothing on the outside, you can just drop the parentheses. All right, so you have 7 plus 3i plus 5 minus 4i, okay? As long as it's addition, right? If it's addition in the middle, you can just drop the parentheses. Okay, and now we're just going to combine like terms. Okay, so 7 is a constant term. So we look for another constant term, 5. 7 plus 5, that's 12. Right? Then you look at your imaginary part. Here you have a positive 3i plus a negative 4i. So that's going to be minus 1i, or you could just rewrite it as 12 minus I. Let's do Okay, we'll do one more addition. So here I have 1 plus 2i plus 3 minus 2i. And again, so it's plus there, so I can just drop the parentheses. So I'll just erase those. So my real parts, I have 1 plus 3. Now, if you would like to, if you feel you need a little more organization, okay, write them together, right? So do your real parts. So I'm just going to write it as 1 plus 3. Okay, that's my real part. And then my imaginary part is 2i plus negative 2i, right? Because we're adding. So the 1 plus 3 is 4. Now here, okay, we would get 2 plus negative 2 is 0i. So here we added two complex numbers and we got a real solution. All right, so that may happen. You may combine complex numbers to get a real solution. Any questions so far? Okay, and again, just like I said before, okay, if it helps you, treat these like, variables, right? So if this was 1 plus 2x plus 3 minus 2x, well, a positive 2x and a minus 2x, right, they would eliminate each other, and you'd just be left with the 1 plus 3 that gets you 4. All right, let's take a look at a subtraction problem. Excuse me. Daylight savings messed me up. Okay, so here we're subtracting two complex numbers. So the first part, okay, we could just drop the parentheses, right? I'm not doing anything to that, right? I don't have to distribute a number. But now in the back, for this back half, what I'm going to do is I'm going to distribute this negative 1, right? Because technically there's a 1 in front of it. So I'm going to distribute this negative to both of those terms. So that becomes minus 5. And minus negative 3i becomes positive 3i. Right? And now we're just back to combining like terms. 3 minus 5 is negative 2. 4 plus 3 is 7. All right, let's do one more, a little more complex. All right, so now we got 3 terms. So we're going to kind of handle it like we did up here. Okay, we're going to distribute what we need to distribute, and then we're just going to combine like terms. All right, so I want to get rid of these parentheses. Well, this is a pure imaginary number, but there's nothing I can do with that right now, so I'm just going to rewrite it as 2i. Again, as long as you see a positive, a plus in front of something, then you can just drop the parentheses for that part. So this will be plus, well, it's plus negative 3i. So actually, yeah, I'm going to write it like that for now. Plus negative 3 plus negative 4i. Okay, if you would like to change that to minus 3 minus 4i, that's up to you. But now we're subtracting, so again, I have to distribute that negative into both of those. So this becomes a positive 3, and this becomes a positive 3i. Right, so here I did a little differently, and I'm I have addition everywhere, and I grouped that negative in instead of making it minus. Okay, so this part you don't have to write, but this could be rewritten as 2i minus 3 minus 4i plus 3 plus 3i. Okay, both of those are equivalent. Here, like I said, I just isolated the negatives. All right, now that we have all the parentheses removed, combine like terms. Negative 3 plus 3, well, that happens to be 0. Two I minus 4i would get us negative 2i. Negative 2i plus 3i would just be 1i. All right. Any questions? All right, so Wednesday, we are going to continue. We'll do multiplication and what are called complex conjugates. All right, so that, if you're a little iffy on this, you probably won't remember the complex conjugate part.